Hello explorers and welcome to another video. Today we're going to talk about Löve2d or Löve2d, and I made a game. So in this video we're going to talk about this little game here that I made in the 3D engine Löve2d or 2D engine. And I built some interesting features into this, and I tried to create some enemy that can run on this platform over here. You can jump around and you can collect stuff and get the score, and I also have some dialogue in the game, just so I have a dialogue system and so on. And many of these things were quite easy to get started with, and I thought it was really fun to actually be able to create something that you can play around with and design your own. And so I'm gonna show you some of the parts in this game to either help you if you want to start off building your own game and try this engine out, or just inspire you perhaps to look into game development or other things that could be really fun to play around with. So this is my little game map over here. So it's a tool. There's a tool called Tiled where you can draw maps like this. And as you see here, this is the full map that I've drawn so far. And you draw it by actually putting some tiles on the window. And there's a lot of tutorials on how to use tiled. Things that I found that were interesting to learn about was, first off, you have this tiles down here. And if you have imported a tile sheet, all of these have properties. So if you go into the tile editor, you can see that these have properties. And one of the things that you need to add to them so your model can actually stand on things in a platform game is this collision box. So you need to add collision boxes. And in Löve2d, I use a library called STI, or Simple Tiled Implementation. And if you say that something is collidable in that implementation, it will actually be something that you can stand on. And if you say that it's collidable and a sensor, you can not stand on it, but you can collide with it and get a reaction on that you collided with it. So that's interesting, that you need to go into tiles and actually add these. You can add these properties to each part of the map if you like, so you can draw rectangles where you can stand and so on. And if you're creating a really large map and want to save memory, that could be something that you want to look into. But what I did instead was saying that the tile should have these references or properties, and then I resolve object types and properties. That means that every tile that you add and put properties on, it will merge those to the map, so you can reuse them in your system. So if you look at this little enemy here, so this is not the actual sprite that I use for the enemy, but I have put the type enemy on that, and this sprite I've put the type collectible, so I can find them in the engine and use them for my game. So I draw this up here, and I have two layers, one map layer where I actually draw things, and this is a tile layer, and then you have an object layer where you can put some objects. And at the moment I have put opacity 0 on that, but if I put 1, you can see where all the objects are placed. But you want to have it at opacity 0 if you want to handle these objects yourself in the engine. And I found that handling all the objects in the map is easier if you want to remove them, or if you want to have them moving around and so on. There might be an easier way to do this, but this is how I did it. So let's look at the main program today, or the main game. So and it has a few modules that I use. So I have a player, an enemy, a collectible, and dialogue that I have written. And we might be able to look in one of these. Perhaps they are a little bit complicated, so I might want to take another video to explain each of these. But we need to hold the window height and width, of course, because we do calculations of those. We need a map and the world. And the difference here is that the map, that's the actual tiling and everything that you see. The world is a physics world. So that's things that actually makes your character drop, or where you can push a character in one direction. So it's the actual physics that is happening. And then we have the background sound, we have collectibles and enemies, we have our hero. I can mute my sound. I need a counter how much time has elapsed in order to actually do some animations, and I keep a score. Then I have two functions here that I've created for ease of use. So I have one print table, because pretty much everything in this engine is tables, and tables you can evaluate, or they are pretty much equal to maps. But objects are also tables, so it's very close to JavaScript when you're writing these. And then I have a reset function here that will put everything to 0 again, and that's used when I restart the level or restart the game. So we have three parts that are the main of the game, so to say. You have a load function that will run once. You have an update function that runs a lot. It's very fast. And then you have a draw function that draws things to screen. And this draw function will draw things in 60 FPS or in 60 Hertz. So every 60 milliseconds it will draw something. The update function runs much faster, but there you should do all your updates in the update function, and the draw function and the update should be not connected. And then you have a key press, and this is to handle all the key events. And then I have some callback functions for actually looking at colliding objects. And the only one that I've implemented anything is in begin contact. So that's when something is colliding. So let's look at the load function here. We set the window width and height. We create the background sound and start playing that. We set the random seed for our math function, and that's when the actual typing is occurring. It's using a random seed, so it looks a little bit more like typing when the actual text comes out. And then I put my physics engine here into setting the actual pixels for 1 meter in the world. And that's important to get the physics right. And then I create my main dialogue engine, and I set my map here. So this is the only row that you need to actually have an SDI map implementation in your game. So when you have drawn your map, you just run this and you have a map. Pretty much. Here I set up my world physics, and I say that it should have the same. So this will actually say that we want something like Earth gravity in our game. And then I set callbacks here, and this begin callback, end contact, pre and post solve. And pre-solve is actually before the contact happens, so you can look even before you have hit something. And then I initialize my world. So Box2D will handle the actual collision in the game. So Box2D is initialized in the map. As you see here, you can use more than one or a different implementation if you like. There is also Bump, which is another library that you can use to handle the physics and colliding. So there's a physics engine in the actual Löve engine, but there is no collision handling. So that's what you use that for. And then I need a start position for my hero. So I look for the start position among all my objects. I also find all the enemy objects and put those into an array here, or a table. And then I find all my collectibles and add those to my little collectibles table here. And I create my little hero, and I give the hero half of the window width and height. And I will use that later to actually figure out where the hero should be positioned and where the screen should be positioned. And these two function here is for a library called Lurker. And Lurker is a library that can do hot swap in your game. So you can have your game running all the time and just do code changes, and they are actually updating on the fly when you're building things. And that's very nice. One thing that I found was that I wanted to, before I swap everything, I want to reset everything, because if you don't do that, you get a lot of collectibles, you get a lot of enemies, and the state is kept, but the drawing can be a bit off and it can be a little bit weird. So resetting everything before you actually reload is quite good. And then I have this post swap, and this is when things have swapped. And if I actually did a change to the map, so if it sees that the map is changed, then I want to do a reload as well. Otherwise it will do the reload or swap in the file, but it will not trigger any reload of the actual game. And as I did a lot of map changes for a while, I wanted to have that in here as well. So that's the load function. So what we do when we start our game. And then we have the update function here, and I put update lurker at the start, and that's just for this hot reload. So if you are not needing any pre or post swap, this is the only line you need to actually have hot reload of your engine, which is quite interesting. And then we have two keyboard combinations here, left and right, to actually move my hero left and right. And this is I put this here in order for you to hold down the key and move in one direction. If you put it in the key press, then you need to press the button every time you want to move somewhere. So this is so we are able to hold down a key and actually move in that direction. And then we need to update the world, update the map, update the hero, update all the enemies, and we also need to update the main dialogue. So they update all the things in the update function. And then in the draw function, it's pretty much the same. We need to draw everything. So here we draw the map, we draw the hero, and we draw the collectibles and the enemy. And on the top here I have a little check, because the hot reload sometimes didn't get things right, so I lost my map. So if I don't have a map, then reload everything. So that's a safety measure, so the game just continues working. The reason I put white here is that you actually want to see something. So everything is drawn to this color, but if you put black here, your screen will be black, so no color will be printed. So that's good to know. If you're using this, you need to actually set white as your drawing color, even though the map has different colors. And then I have my draw my main dialogue, and I draw my score down here. So I just put in some values for my score. I also have a little debugging here if I want to see all the objects and their collision boxes. I can turn this on and I will see the collision boxes in the game. So that's the draw function, and the key press function is quite simple as well. I can press R to reload everything. I can press space to say the next line in my dialogue tree. And then I have up down to jump and stop. And I can also quit the game with escape. And then we have this contact function down here. And the contact function will look for different sensors in the game or different collidables in the game. So this will trigger quite often because we always collide with ground, and the enemy will collide with ground as well. So there is a lot of collisions happening, and I actually just want to look for collisions of the type sensor. And I have two different kinds of collisions. So first off, we have the collision when we have a sensor and the user data have properties. And in this case, the actual fixture comes from the map, because in the map you have properties and objects on your fixtures. So the map will create objects and properties, and I will set a few properties in the map in order to trigger things. So I will look here, do I have something with a sensor, and does it have properties? Then I will know that this comes from the map. And in the map I have in the top properties something that is a type dialog, and then I also need to check what I collide with, if it has a type, and if that type is a player, then I want to actually run a script. So I will use my dialog module, and I will start the script. And this script is also added in the map. So we can look at that fast here. If we look at the objects and we look at dialog intro, for instance, this is here in the map. And over here you have the properties, and this is collidable, it's a sensor, it's the script intro 1, and we have the type dialog. So I put everything in here where I want this object to be, and also what I want to happen when this object is actually collided with. So that's the collision box for my dialog. So that will start a script. We will look at the dialog engine some other time. And then we have down here a sensor, and if the sensor have a type, and that's the objects I have created, because I want all of my objects to have a type function, so I can actually check what type of object is this. And if this type is a collectible, so it's one of the objects I created earlier, then I will check if it's the player, another object, that actually collided with this collectible. Then I will just run collect on that object, because I know that collectible have a function collect. And then I will destroy that, and I will update the score. And the reason why I destroy on both sides here is that I want to destroy the fixture, so this sensor will not be triggered again. Because if you read a dialog, or if you collect a gem or some collectible, you don't want to collect them again. You don't want them to be in the map anymore. You want them to be removed. So that's pretty much my little game here. There's a lot of moving parts, and we haven't actually looked at the different objects yet. We have just looked at the game engine, but all the code is on my Git repository that you can find down in the description if you want to look into the code yourself. I actually am going to be a part of a game jam that will build a game on during 14 days. So that's why I've started with this a little bit. And I actually started well before the date that we actually wanted to start this game jam, but it's going to be really fun to actually play around with this and build some interactive game and see what I can do with this. So I'm really excited for this. I hope that you found this interesting and that this made you excited to actually look into game development, perhaps. If you have any questions, please leave them down in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues, and if you haven't subscribed yet, please do that, and I really hope to see you in the next video.